Good morning, Tahmina Khan is here in TKMaths is fun. This is part number 9 on videos on integration, and in this video we will study past paper questions. We have completed the concept of integration in the previous 8 videos. In this video I have selected 2 questions for explanation and 3 more questions for your reference for your practice. So let's begin with the question. This question I have taken from June 14, variant 3.1, question number 2. This is a question of integration by substitution, which is very obvious from here. This you have to integrate, and the important thing is that you have to give answer in the exact form. So you will not write answer in decimal form, so avoid making this common mistake. So let's begin. We know that integration by substitution, when we do, whatever the substitution we are taking, we differentiate it with respect to the variable present here. So I will find out differentiation of u with respect to x. And why do we do this? To get the value of dx, because wherever you have x here, you have to replace it by u. Okay? So I'm differentiating u with respect to x. Differentiation of a constant number will be 0. And differentiation of tan x will be sec square x. So it is 3 sec square x. After that, I am separating x and u. It is the method called separating the variable. So I'm separating the x and u here. So it will become 1 over 3 du is equals to sec square dx. Now, remember, whenever you do substitution, whatever you get after differentiation should be present here. At a glance, it doesn't look like, because sec square is not here. But you know sec square is a reciprocal of cos square x. So I can write sec square x as 1 over cos square x. So it means this thing 1 over x square, 1 over cos square x dx can be replaced here by this. We will see it how if you are not sure, right? Because there is a basic concept required. Let me explain here only. You must know when you write a over b, it means a multiplied by 1 over b, right? So similarly, root 1 plus 3 tan x multiplied by 1 over cos square x dx. Okay, so that's why this part we will replace by 1 over 3 du. And 1 plus 3 tan x will be replaced by u. So we will see it, but the important thing to take care here is the limits. These limits are with respect to x. We have taken a substitution. So we need to change the values of limits also. So your function is u is equals to 1 plus 3 tan x. Now when you put x 0 here, right, you get u1. Why? Tan 0 is 0. 0 multiplied by 3 is 0. So you will get 1. When you substitute x pi by 4, the upper limit, tan pi by 4 is 1. So this thing will become 1. 1 multiplied by 3 is 3 plus 1 is 4. You got your limit 1 to 4. Here it was 0 to pi by 4. So now we have taken care of everything. Let's start replacing it. So limits will be replaced by 1 to 4. And here it will be root u, because 1 plus 3 tan x is u. And 1 over cos square x dx will become 1 over 3 du, right? So after that, the integration is very simple. We know the integration of root u will be 3 upon 2 divided by 3 upon 2. And then you will take inverse of it, 1 over 3 multiplied by 2 over 3, and applying upper limit minus lower limit. Because it is a constant, I'm taking outside the bracket, right? So after that, you can use calculator because you're allowed, and get the answer. Do not write answer in decimals. Again, you can write in the mixed number form, you can write in the fractional form, that is fine. Let's see the next question, which I have picked up from November 18, variant 3.2, question number 3. At a glance, you can see it is integration by parts, right? Because if you differentiate ln x, you will not get anything like this. If you differentiate this, you will not get ln x. So this is not a case of substitution. And whenever we have functions in the form u into v or u over v, we have two methods to solve them. integration by parts and integration by substitution. Okay, so whenever we do integration by part, first of all, we should know the formula. I will show you. This is the formula. uv prime is equals to uv minus vu prime. So important thing is that out of these two functions, which one you will take as u. So you remember the word late, which helps you to identify. This sets the priority of selecting u. So log is present here. So my u is ln x. Again, this thing means, okay, I've written here. So this thing means ln x into 1 over x cube, right? So this is my u and this will be my v. So my u is ln x. I'm differentiating it. It will be 1 over x. I'm trying to find out u, v, vu prime, so I can substitute here. Now my v prime is 1 over x cube, right? This function is my v cube. So v prime is x power minus 3 because now I need to integrate this function to get v. Here I differentiated to get q prime, and when v prime, it means differentiated function is given to you, so you will integrate it. So it is simple, x power minus 2 divided by minus 2 is equals to this. Now I will plug in these values u prime here and here. And v is here, right? So now let's substitute the values. So my u is ln x, my v is minus 1 over 2x square, right? Minus vu prime. So v is again minus 1 over 2x square, and u prime is 1 over x. So I have simply substituted the values here. So now we will simplify it. This is the substitution. So it will be minus 1 over 2x square ln x, minus minus is plus, 1 over 2 I'm taking out. And now I will integrate this. Now this is something we can integrate easily. And you get c also here. Why? Because there are no limits. This is indefinite integral. So you will write c here. And after that, minus multiplied by plus is minus, and 2 2s are 4. So you got your integration of this function which was given to you here. So integration of this function is equals to this thing. Now let's see part 2 of the same question. It is the same question, but now it is saying 1 to 2. When the word hence come, it means you have to make use of the answer you are getting in the above part, right? So now we have already integrated this function. So we will just apply limit 1 to 2 on it. And the important thing is to bring it into this form. So you cannot just plug in the values in the calculator and get answer in decimals. That won't help you. So now we have seen in part 1 that the integration of ln x over x cube is equals to this thing. It means we know the integration of this, which is here. And now the limits are 1 to 2. So I'm applying limits on it. Do you see I did not write c now? Because whenever we applied definite integral, the c cancels out, right? So now it will be upper limit 2 you will apply here first of all, wherever you have x. I have done here in green color, you can see. And then minus lower limit. Wherever you have x, you are writing 1. Now notice one thing. Here it was minus, right? Why did I write plus here? Because I've taken minus as a common factor out. Just to facilitate myself, if you want to keep it inside, there's no harm. I want to keep minus outside. It helps me to work smoothly. No chances of error. So upper limit minus lower limit. And we have to bring result in this form. So we will have result in front of us all the time so that we can keep changing or manipulating the expression and bring it into this particular form. Now, denominator is 8, 2 2s are 4, 4 2s are 8. This is 16. ln 1 is 0, so I'm writing 0 here because 0 divided by 2 is 0. minus multiplied by plus is minus 1 over 4. Now these two numbers, when you subtract 1 over 16 minus quarter, you get 3 over 16, right? And now how can I bring it into this form? I will take LCM now, and LCM will be 16. So I will multiply this by 2. So it is 2 ln 2 over 16 minus 3 over 16. Now, if you remember the power law, when you have a ln b, for example, you can write it as ln b power a, power law. So I'm bringing this to here. So it will become 2 square, and 2 square is 4. And this is what I want here, you can see. So it will become minus ln 4 minus 3 over 16. Now I can take 1 over 16 out to bring it into this form and multiply this. It will become minus plus is minus, minus minus plus. And I will get the form which is given to me in the question. So this is how we will solve the question. And now the 3 questions I'm giving you for reference. Answer from the marking scheme I've put up here. Though the marking scheme of P3 does not help a lot, but it helps to check the in-between steps and answers finally, right? So this question is from June 1933, question 2. You can open your past paper, or you can put the video on pause and do it here. Again, you have to bring it into particular form. Let me help you. You will apply integration by parts here again, because two functions are totally different. If you differentiate one, you don't get the part of the other one. So you will apply integration by part here. Here again, you will apply integration by parts. X minus 3 and ln x. This will be your u, and this will be your v prime. I'm just giving you hint here. Paper is taken, question is taken from June 1903 to question 4. By the way, here, what is your u? If you remember the word late, just a hint, log is not present here. Algebra, polynomial, yes. So this will be your u, and this will be your v prime. Okay. So these are the questions. There was one more question. Yes, here. So this is from June 1433, question 9. This looks difficult, but actually it is not. And you will apply differentiation also in it to find out the value of m. So an answer of this question is again here. So you can put videos on pause, practice these questions, or note down and do it later. You can ask 2 queries, because I'm offering this offer. I'm offering this. Those who get these videos, I can help them in their 2 queries. Otherwise, from my website address, you can contact me and ask for the help from the category which says question help. So you can register yourself, or you can just send a WhatsApp message that I need help or tuition for question solving, because I am giving lessons or tuitions for the whole course, for topic, and for questions also. So that is like very minimum, bare minimum cost. So thank you very much for watching this video. I hope it has helped you, and it will help you to solve your more questions. Do share it with your friends and other people who are in need. Thank you very much for watching. Take care. Allah Hafiz.